Now we're going to differentiate natural exponential functions. But first we have to know the derivative of e to the x. You're going to love this. The derivative of e to the x is e to the x. When we're dealing with natural exponential functions, it is often taken the derivative along with the chain rule and the product rule. For example, for the chain rule, if we recall, the derivative of a function within a function would be the derivative of the outside function, leaving the input function the same, times the derivative of the input function. So if we're dealing with the derivative of e to the f of x, we would first take the derivative of the outside function, which is itself e to the f of x, times the derivative of its exponent, the derivative of f of x. So let's take a look at a couple of examples. In example A, we have f of x equals e to the 2x. So to take the first derivative, we would take the derivative of the e to the 2x, which is itself, times the derivative of the exponent, which is just 2. So this gives us 2 times e to the 2x. In B, we have the equation y equals the natural log of x times e to the 3x plus 2. Notice that multiplication. Let's recall our product rule, where if we have two functions being multiplied and we want to take the derivative, we take the derivative of the first function times the second function as it is, plus, then we leave the first function as it is and multiply it by the derivative of the second function. So to find y prime, we would take the derivative of the natural log of x, if you recall, is 1 over the argument x, times the second function as it is, e to the 3x plus 2, plus, now we leave the first function by itself, natural log of x, times the derivative of the second function. Well, again, it's e to an exponent, so the e derivative would be itself, leaving the exponent the same, times the derivative of the exponent, which is 3. If you need to pause the video so you can kind of grasp where all of these pieces are coming from, please do so. Now let's do a little algebra and clean it up. The first piece being multiplying gives us e to the 3x plus 2 over x, plus, I'm going to move that coefficient of 3 to the front, 3 natural log of x times e to the 3x plus 2. Once you're here, technically you have found the derivative. Sometimes you're asked to simplify it further, and that would mean that we would divide out this common factor of the e, and again, this is optional, but sometimes one format is easier to work with than another. So be sure you understand how to factor out the GCF if necessary. In example C, we have the function f of x equals 5x squared times e to the 7x. Again, I would consider these two pieces, the fx squared, as one function being multiplied by e to the 7x as a second function. So we can use the product rule. Derivative of the first times the second as is, plus the first as is times the derivative of the second. E to the 7x times the derivative of the exponent, which is 7. And again, let's clean it up. And if we need to simplify it further by factoring out the GCF, we can see that both terms there have a GCF of 5 between the 10 and 35. Between the x and x squared, we have a GCF of an x, and they both have an e to the 7x. Factoring that out of both, that would leave us with a 2 plus 7x. Example D, we'll use the chain rule again. The derivative is the derivative of the outside, or e to the 5x cubed plus 2x squared minus 5 as is, times the derivative of the inside function, or in this case our exponent, which would be 15x squared plus 4x, and the derivative of the negative 5 is 0. There's nothing to factor out there, so we can leave it like that. In example B, a company's monthly sales is represented by S of t equals 2,000 times e to the 0.08t, for T is the number of months. It's asking at what rate does the monthly sales increase or decrease in the 7th month. So again, S is representing our monthly sales, and T is our time in months. Well, in order to find the rate of increase or decrease, remember increase or decrease, this is our hint as well as the word rate, that we're looking at our first derivative. So if we take the first derivative of our function, we would get 160 times e to the 0.08 t. Well, they're asking us for a particular month, the 7th month. Plugging in 7, we will get 280.1076. This can be interpreted as, in the 7th month, the sales were increasing by approximately $280.11 per month.